So good afternoon, everyone. Welcome to the Google Cloud Study Jam Session 3. So today's agenda is more about Gen AI, GANs, and cloud and generative AI. So firstly, we'll start with Gen AI. So in this picture, we can see the first picture, we see traditional programming. That is what we program every day. The second picture we see is neural networks, where we are just showing a picture of a cat or any other object of our wish and training the model to identify it. In the third picture, we are giving it a set of data, a huge data set, and telling it to learn by itself, like by giving different examples. And at the end, when we ask it what a cat is, it explains us. So Gen AI is basically a type of artificial intelligence that can create new data. And for giving us an example, imagine you're having a very super smart friend that does all your work or homeworks, etc., etc. And because they've learned so much from reading and listening. And generative AI with large language models is like having the super smart friend because it has trained with a lot of examples, and that personal assistant is having that enough brain power. So generative AI with a generative model and large language model helps it make it happen. Gen AI, that is the large language models, can be used in different applications, and few of them are content generation, natural language understanding, translation, and gaming. So in natural language understanding, it's used mostly in virtual assistants, chatbots, and etc. And for gaming, it's mostly used to create dynamic experiences for conversing with others.
So until now, we have seen in Gen AI that the goal is to enable machines to produce creative and realistic data, like mimicking human-generated data specifically. Now, today we will be learning about a powerful tool under Gen AI, which is called as GANs. When we come into GANs, technically used for creating data such as images or text or music. Basically, it will be very realistic and it is very similar to the data, predefined data we have. But we are not copying it, but we will be generating it. So now let's go into GANs. Short for generative adversarial networks. Let's divide this GAN into three words. Let's see. First one, generative. As the name, as the word itself, to generate new data. Whereas adversarial, it means for competition or conflict. We'll be seeing soon that about it. Now networks. So when we come into networks, uh, basically these are inspired from our own brain, neurological neural networks of our brain. Under GANs, we have three components. One is generator, discriminator, and how the competition works between the generator and discriminator. So you can think of a generator as an artist, which creates a fake data, which is very realistic and similar to the original data. And the goal of the discriminator is to examine this data and determine if the data coming from the generator is real or fake. You can think of the generator as a thief who is trying to create a false information, and discriminator as a cop who is trying to find the thief. Now, in the under generator, we will be having some initial points or initial states, creating random noise and using mathematical operations to simulate the data to obtain the false information we need. From that, then we will be showing that to the discriminator with the real data itself. So now discriminator will be classifying the given data by the generator if it is false information or wrong information. So under like this competition always exists between generator and discriminator. Now how the training loops goes is, after discriminator gives the feedback to the generator, or it gives a score or a probability how real or how fake the given fake data is from the generator. From this, the generator obtains the knowledge of how should I improve more. Whereas the discriminator, during this whole competition, the discriminator and the generator will improve those both skills. whereas the discriminator will improve its identification and classification of the fake data. The training loop stops when the termination happens, like when the generator improves its to the full potential to create the fake data to the most similar to the data set we have. Now the discriminator can't identify the fake data as fake. Then the training is stopped. Now we can use our GAN model to generate the fake data. Now here we can see the model. We have training set, generator, random noise, and discriminator. So here we are looking, the generator takes the random noise and creates some fake data and sends to the discriminator with the training set. Let's take an example. Uh, how many of you have been through deepfakes? Anyone knows about deepfakes? Yeah, it's basically fake images, fake videos, forgery basically of humans though. So now we will be, let's say how fake image generation is happening through GANs. Now our discriminator is already trained with the real data set. After that, we will be, the generator is more like a expert forger who can create fake images of the fake images of the human. Now we will be sending the images of the fake data and training set to the discriminator and classify which is real and which is fake. And then the discriminator gives the feedback of the human face and emotions, how real or how fake is that. And at the starting, generator can maybe using random noise, maybe it is just a pixels, maybe it can start from pixels, but giving it to the discriminator and getting back the feedback, it will improve its own mechanism of creating images. So now here we can see the applications of GANs. One is image generation. The main the applications of GANs is not only image generation, the data generation, but mostly the image generation is because of the neural networks it consists. We can create a fake image generation as we seen in the previous slides, whereas deepfakes comes under the image generation itself. Whereas super resolution, I know there are many algorithms to enhance the pictures, but why GANs are useful is because we are implementing a deep learning model and giving it the data set, and then we are getting the feedback. Whereas the previous models we have under super resolution is like maybe having taking the pixels and combining with the consecutive pixels. Whereas in the style transfer, let's say you have your own image and you want to convert into the comic type of style or cartoon type of style, how you will do it? So by using GANs, we can combine the relationship of the specific cartoon or the comic to the relationship of the our image. Basically we have seen generator and discriminator. While using images, we have always a linear relationship between the images during classification. So whenever our generator uses random noise to disturb the linear relationship between the images, so that it can improve itself in the fake data to create the fake data to obtain the better results, it will disturb the relationship and try to regain the relationship by using the fake data.
So we'll be moving into cloud and the relation between cloud and Gen AI. So we'll start off with a small example to show the relation. How many of you cook here? Yeah, so to cook, you'll need a proper kitchen or a setting, right? So I'm taking that example to give a basic relation. So think of generative AI here as a smart chef who can cook all sorts of dishes for you. But this chef also needs a special kitchen. So this kitchen is like the cloud that we have. And this cloud, that is the kitchen, is also equipped with different ingredients, techniques, or recipes for cooking. And generative AI here is your talented chef. So the chef also knows how to create amazing recipes. And when these both combine, it will. So when you ask for a meal, and the chef goes to the kitchen, cooks your meal with the ingredients that are there in the kitchen, and then gives you back the completed item. So that is basically the relation between AI and cloud here, where AI is the cloud is the power that you have. So in simple terms, what we can tell is cloud is a giant power that, like a toolbox that gives you the power, accessibility, and storage that is required for the Gen AI to work properly. And so the important parts that Gen AI needs is data storage, accessibility. So Gen AI models, when they have a vast data set. So to have like scalable options for these vast data sets, we need data storage. So that cloud gives us. And so next, coming to deployment, security, updates, maintenance. So after these models, the generative AI models are trained, they can be deployed onto cloud, making them accessible to all the other developers who can use these models through APIs. And that also cloud only gives, so that every other developer can use it. And many cloud providers offer managed AI services like machine learning, deep learning networks. Coming to the maintenance part, developers like can focus on the AI infrastructure that is there, that is given by cloud. And security is one of the major things that generative AI models need, because there's a huge data set, and that also cloud provides. So basically, that's it, the relation between cloud and Gen AI. Over to Naveen.
Uh, Good afternoon, people. Thank you, Egna and Kavya, for the wonderful talk. So I think we would have learned a lot about Gen AI in their previous sessions and the last session. I think we have learned ample, so let's deep dive into cloud computing. So I'll tell you what cloud computing actually is. It is a technology wherein we use the remote servers to like save data. Data can be of any type, including images, pictures, art, GIF, music, videos, whatever you tell. And let's see what it is different from the previous or the conventional way of saving data in a reserved place in every company. So in a reserved place, what other companies does in past is that they have a data center set up in their area. They have to manage it. They have people who are like using data, storing data, doing multiple stuff of data. So that was time consuming. It had a lot of amount to be spent. So let's see how cloud computing made it better in terms of saving data. So few benefits of cloud computing or the need for cloud computing is scalability. So what do you mean by scalability? Scalability is basically a fact that you can use how much of a data you want. For example, imagine a company hires like 100 new people. You, in a basic setup, you need to add few things that like get more data to be stored, or you fire 100 people, you you have wastage of data storage spaces. So what cloud does is basically you can set the amount of data that you want. So you can horizontally scale the data or a vertical scale the data, wherein if you want to like scale the data, increase your amount of data that you store, you can do that. And when you want to reduce it, you can like do that. It's open to everybody who does that. Cost effectiveness. So talking about it, everywhere you go, cost is a matter. And when you're setting up sessions, when you're like doing this, you spend a lot of money, you tend to spend a lot of money, but being in cloud would reduce the amount to really low than what we actually spend in I mean setting up data centers. So yeah. And accessibility. So one example of accessibility is that I can access it here in my laptop, and imagine I go somewhere else and I need to like access my file. I can do that. So that is accessibility. It is flexible. I can access it from anywhere. That's all it means. And imagine you have a database center and your data is like corrupted, maybe a natural disaster or anything like that. The data is gone. And all of you might have already known the importance of data in everyday life. Data is really important in doing things that we do regularly. So imagine that's gone. We don't have a deadline, but in cloud, people prefer storing it in multiple areas, multiple countries, multiple regions. I'll tell you more about it in later things. So that's one betterment of data. We have many policies on, and that like enables the security of data. Imagine how many of you know about Netflix and Hotstar. Disney Hotstar. So everybody knows it, right? Imagine that both are handled by a company known as AWS, Amazon Web Service. So imagine that Hotstar's data is like transferred to Netflix, and Netflix data is like sent to Hotstar. So it is like sharing their things that is not in under their jurisdiction. So we have policies in cloud that like handle that, and that's something about security and compliance. So let's see how a cloud service model works actually. We have three models, one above the other. One being the IaaS, which stands for Infrastructure AAS, and PaaS, which stands for Platform and Service. So let's see more about it in next slide. So imagine you logged in into your GCCF, you started doing a lab, and you have only little time left out on doing the lab. And imagine you want to have pizza. Appetite for pizza is never ending. So imagine you want to have a pizza. What do? Take out your phone, Swiggy, Zomato, order a pizza. That's what everybody does. So that is basically SaaS. Everything, including the base, how it is customized, everything is taken up by the company, and you just need to like consume it. It is something ready-made. Imagine you have some time left, but you just want to have a pizza. You would buy a base from a market and then like add toppings onto it, the toppings that you like, preferably, and you'd cook a pizza. That is what PaaS does for us. And what does IaaS does for us? Imagine there are like multiple kinds of pizza: cheese crust, thin crust, handmade, multiple things. So imagine you want to make a complete pizza for yourself. So in that case, you would use IaaS. That basically is like you need to do everything: buying yeast, buying dough, buying maida, whatever to buy for a pizza, you do that. So that basically like sums up the difference between IaaS, PaaS, and SaaS. So when I'm going in a technical sense, we have multiple aspects of cloud computing, which is network, storage, servers, virtualization, operating systems, middleware, runtime, data, and applications. Most of us prefer using applications directly, but then we being our engineering career, we use PAA sometimes, SAA sometimes. So this is like a technical view of what I was talking about before. Now let's see about top 10 companies that provide cloud computing. So the top 10 cloud providers are AWS, Azure from Microsoft, Google Cloud, Alibaba Cloud, Salesforce, Dell, IBM, DigitalOcean, Adobe, and then Dropbox. So the Google Cloud, we are like into the Google family. So we are like going to talk about Google Cloud. So Google Cloud offers their services in 5 countries. They are divided into 5 continents, rather, jurisdiction, which is North America, South America, Europe, Asia, and Australia. They provide the services for cloud in these continents. These continents are divided into multiple regions. For example, region number 1, maybe Europe West 2 is London, and London has 3 zones. So one region can have multiple zones. And then we'll see what resource redundancy means here. So why do you need to store it in multiple regions? Why do you need multiple servers in multiple countries? Why do you need multiple zones? One major aspect of it is resource redundancy, wherein you save your one data in multiple continents, multiple zones. You save it in multiple areas. So that's why it's really important to like use cloud. And Google has 103 zones and 34 regions. And that's the end of my presentation. Thank you.